My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Imagine you have a pizza and want to share it with your friends. You cut the pizza into 8 equal slices and each friend gets 1 slice. But what if you want to give each friend half of a slice? The original slices were 1/8 of the pizza, but how large is each slice after cutting them in half? What if you were a chef baking a cake that calls for 3/4 of a cup of oil, but needed to make 2? How much oil would you need? Suppose you were a farmer with a 3.5-acre field and plan to plant 1/5 of the field with wheat. How many acres of wheat will you plant? Each of these situations involves multiplying fractions. But before we get into the mathematics, let's look at what multiplying fractions means. Fractions represent values that are not whole numbers. For this video, a fraction is any number a over b where a and b are whole numbers. The value above the vinculum is called the numerator and represents the number of equal-sized pieces used to represent the value. The number below the vinculum is called the denominator and represents the number of pieces the whole is divided into. For example, 3/4 of a pie means you would have 3 pieces if a whole were divided into 4 equal-sized pieces. When you learned about multiplication, you may remember it being called repeated addition, as it is a way to count groups, sets, or rates. For example, if we have 5 groups of 2 apples each, we can represent this as 5 times 2 equals 10, or 10 apples. Similarly, if we have 5 groups of a half apple each, we can represent this as 5 times 1/2. Notice that this gives us 5 half apples, which is the fraction 5/2. Converting this into a mixed number gives 2.5 apples in total. This means we have a total of 2 whole apples and half of an apple. In this case, we counted 5 groups of 1 piece, with each piece being of size 1/2. The final answer is in terms of whole apples and parts of an apple. Let's go back to the cake I mentioned at the beginning of this video. Each cake requires 3/4 of a cup of oil, and I must make 2. I will represent the situation visually first to find the total amount of oil. One way is to make a drawing. I will draw a circle with the fraction 1/4 inside to represent 1/4 of a cup. For this problem, I need 3 circles for each cake, thus 2 sets of 3 circles. Counting the result means that we have 6 1/4 cups of oil. Combining sets of 4 circles to make a whole, I get the result of 1 whole and 2/4 cups of oil. I can then simplify the fraction to 1 and 1/2. For this visual representation, I broke my representation of the fraction down to unit fractions, or fractions with a 1 as the numerator. It is easy to count the pieces and combine enough to make a whole using unit fractions. Next, I will represent this situation with the math expression 3/4 multiplied by 2. Thinking about what happened when we represented the problem visually, you may notice that I multiplied the number of pieces, or the numerator 3, by the number of times I counted it, 2. The size of the pieces, fourths, did not change. Mathematically, we begin by writing the whole number as a fraction. Then we multiply the numerators to get the new numerator, and we multiply the denominators to get the new denominator. The product of the numerators, 3 and 2, gives 6. So the new numerator is 6. The product of the 2 denominators, 4 and 1, gives 4. Thus, the new denominator is 4. Simplifying and creating a mixed number gives a final answer of 1 and 1/2 cups of oil. Now, let's go back to that pizza we were going to share at the beginning. We first divided the pizza into 8 slices, then gave half of each slice to friends. I will represent this problem visually using a rectangular array. Begin by dividing a rectangle into 8 pieces in one direction. Shade one of the pieces to represent 1/8. Next, going in the other direction, divide the rectangle into 2 pieces. Shade one of those pieces. This represents the 1/2. In this model, the number of pieces shaded both times is the numerator. The total number of pieces in the array is the denominator. Counting these two elements, we get one piece shaded both times in an array with 16 parts. Next, let's write the problem as a mathematical expression. 1/8 multiplied by 1/2. Notice that the product of the numerators, 1 and 1, is 1, which was represented by the 1 row and 1 column shaded in. Now look at the denominators, 8 and 2. Notice these form the array's dimensions and give a product of 16. We get a final answer of 1/16, meaning that each slice's size is 1/16 of a whole pizza. Finally, let's look at the farm. I have 3 1/2 acres of land and want to plant 1/5 of it with wheat. I will use a similar but different rectangular array. First, I will draw 4 rectangles. I will divide the last rectangle in half to represent the 3 1/2 acres. Now, divide each of the 3 rectangles into fifths. Shade 1/5 in each rectangle to represent the part planted with wheat. With the rectangle that represents 1/2, divide it into 5 equal parts. Shade in one of the fifths to represent the part of the half-acre planted with wheat. Then count the result. 3 pieces are of size 1/5, and 1 piece that is 1/5 of a half. While the pieces of size 1/5 are easy to count, it is more challenging to count the 1/5 of a half. However, in this case, we could divide the other half of the rectangle into 5 equal pieces. The number of parts represents the denominator or the size of the remaining fraction. The shaded part represents 1/5 of 1/2. We get 3/5 plus the extra. If we count the shaded part out of the total, we will notice that the last rectangle represents 1/10 or 1 part out of 10. Adding the 2 pieces together means we need a common denominator. 3/5 is the same as 6/10, which we can now combine with the extra piece for a total of 7/10 of an acre. Finally, let's look at the mathematics. We can write this expression as the product of 3 1/2 and 1/5 like this. In our first example, we converted our whole number into a fraction. We also need to rewrite 3 1/2 as a fraction. Converting the mixed number to a fraction gives us 7/2 or 7/2. Now we can multiply the numerators 7 and 1 together for a product of 7. Repeating the process with the denominators 2 and 5 gives a product of 10. Therefore, we get the same answer of 7/10 of an acre. There are many places where fractions are used, and knowing how to multiply them is very important. From the last 3 examples, you may have noticed that 4 things happen when we multiply fractions mathematically. First, it is helpful to have fractions, so we convert mixed numbers and whole numbers into their fractional form. Next, we multiply the numerators to get the new numerator. Then, we multiply the denominators to get the new denominator. Finally, we simplify the fraction if necessary. In my mathematical world, I have one little problem. I was walking around my neighborhood and noticed multiplying fractions everywhere. Could you help me understand these situations? Have you ever seen a construction worker laying bricks or tiles? They are redoing the facade of a house near me, and the worker needs to make sure the bricks are placed at the right distance from each other so everything lines up correctly. A worker is putting brick along the bottom of the house. Each brick measures 7 5/8 inches long and is half an inch from the next brick. The worker plans to lay 30 bricks across the bottom. What is the total length of the wall with 30 bricks and mortar between each pair of bricks? It takes approximately 1/100th of a cubic foot of concrete between each pair of bricks. How many cubic feet of concrete will be needed for one row of bricks? One 80-pound bag of concrete makes 7/10 cubic feet of wet mortar. Is one bag of concrete enough for 3 rows? A carpenter at the same location is building a rectangular shelf that is 1 1/4 feet long and 2/3 feet wide. What is the total area of the shelf in square feet? She plans to paint 6 shelves of the same size. How many square feet will she need to cover with paint? Further down the road is a park with a basketball court, and I want to shoot a free throw. The free throw line is 15 feet from the basket, but what if I need to take a shot from half that distance? How far would I be? I'm not very good. What if I took a shot from half the previous distance? How far would I be now? I made 3/5 of my shots after making 12 attempts. How many shots did I make? After shooting some hoops, I walk down to the corner store. Their drinks are 1/4 off. A large drink is $2. What is the price after the discount? Rick mentions that hot dogs are currently 1/6 off the regular price of $1.50. What is the price of a hot dog and a large drink? Rick said they have a new drink they made with 2/3 of the sugar of their other flavors. If one pitcher of the other drinks takes 1 1/4 cups of sugar, how much sugar is in one pitcher of the new drink? Rick tells you that every chocolate cupcake takes 1/3 of a cup of sugar and 1/4 of a cup of chocolate chips. How much of each ingredient is needed to make 30 cupcakes? On the way home from the corner store is a small farm with some cows. Each cow is fed 2/3 of a bale of hay daily, weighing 50 pounds. How many pounds of hay is eaten by each cow? Mr. Mortgan has 27 cows fed in this manner. How many pounds of hay is eaten by his cows in a day? The farm also has 15 chickens, each laying 3/4 of an egg every day. How many eggs will Mr. Mortgan collect in a week? Take a look and you will see a mathematical world around you, filled with fractions. Fractions represent parts of a whole, and we use fractions to represent many things. Furthermore, multiplying means we are counting more than we want to add, dealing with rates, finding an area, or investigating a portion of an amount. Multiplying fractions can help you organize, understand relationships, make plans, and solve problems. Skills that can take you anywhere.